the quadratic formula. The big idea is the quadratic formula gives the solutions to any quadratic equation in standard form whose coefficients are known. So what we're going to have is a parabola or quadratic equation that's going to look like this, and there is a formula that's going to tell us our solutions to the problem. And our solutions are found wherever it crosses the x-intercept. Or sorry, the x-axis, okay? Which means they are x-intercepts, okay? So wherever it crosses the x-axis are solutions to our quadratic equation, okay? The quadratic formula theorem says if ax squared plus bx plus c, so our quadratic is in standard form, is equal to 0, and a cannot be equal to 0 because if a is 0, then we don't have a quadratic formula or a quadratic equation, then our x values are equal to a negative b plus or minus the square root of b squared minus 4ac divided, all this divided by 2 times a. Okay? Now, what you're going to note here is do not put all this into your calculator and expect it to do it all the way it's supposed to be done. Break this up into simpler problems. So take what's underneath the square root sign first, do that math, then take your negative b plus and minus that number, all divided by this number, and so on and so forth. And then once you break it down into smaller problems, it makes this big problem a lot easier. I put another note down here. Your equation has to be in standard form. Put it in standard form, then set it equal to 0. For example 1, it says to the nearest foot, how far from home plate was the outfielder when he leaped to catch the 10-foot high ball? So here's the equation that they gave us, and I know you didn't see it, but we're just going to use this so I can show you how to use the quadratic formula. Okay, but here's the equation. Obviously here a is equal to a negative 0.00132. B is equal to 0.545. And C is our constant, which is a negative 6. Okay? Once this is in standard form, A, B, and C are very easy to find. Now all you have to do is plug it into your equation up above here. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug these in. So x equals a negative b, which is 0.545, plus or minus b squared, which is 0.545 squared, minus 4 times a is a negative 0.00132 times c, which is a negative 6, all over 2 times a, which is a negative 0.00132. Okay? Now, if you break this up into smaller problems, once again, it's going to make your life a lot easier. So x equals, this is a negative 0.545 plus or minus the square root of, and I got to take 0.545 and square it, gives me 0.297025 minus, and it's minus because we got a minus, and a minus. So 3 minuses gives me a negative, so 4 times 0.00132 times 6 is 0.03168. And as you can see, I'm just breaking it up into small problems. And then 2 times a negative 0.00132 gives me a negative 0.00264. Okay, so over here it's equal to a negative 0.545 plus or minus, and I'm just going to do what's under the radical now. So I'm going to take this number, I'm going to subtract these, and then I'm going to take the square root of them to give me this number over here. So 0.297025 minus 0.03168. Take the square root of that. Gives me 0.5151. 0.5151 divided by a negative 0.00264. Okay, which is then going to give me two solutions. Okay, a negative 0.545 plus 0.5151 divided by a negative 0.00264, or a negative 0.545 minus 0.5151 divided by a negative 0.00264. Okay? And so, doing this math, I'm going to write my answers up here because I'm running out of room. A negative 0.545 plus 0.5151, and then divide that all by a negative 0.00264. Gives me 11.3, or on the other side, a negative 0.545 minus 0.5151 divided by 0.00264. Gives me 401. .5. So it says to the nearest foot, how far from home plate was the outfielder when he leaped to catch the 10-foot high ball? Well, would the outfielder only be 11 feet away from home plate? Not a chance for you baseball people. Okay? Yeah, that outfielder is going to be out in the outfield, which is 400 feet away from home plate. So yeah, my answer, 11.3, is not a good answer. 401.5 feet, maybe he's robbing that home run ball at the fence. So yeah, 401.5 feet is where that outfielder caught that ball at, 10 feet high. Let's look at example 2. Okay. It says solve 5x squared plus 13x minus 6 equals 0. Okay. Is this in standard form? Yes. Is it set equal to 0? Yes. So what I'm going to do is I'm going to find my solutions. And all I have to do is plug it into this equation right here. So, what's my a? My a is whatever's in front of my x squared, which is 5. B, my b is what's in front of my x, which is 13. And my c is what it is left, or what is my constant, which is a negative 6. Make sure you grab their signs. 5 and 13 are positive, 6 is negative. Okay? Now all you have to do is plug it in. So x equals a negative b. What's b? 13. Plus or minus the square root of b is 13 squared. Minus 4 times a, which is 5, times c, which is a negative 6. All divided by 2 times a, which is 5. So, break it down into simpler problems. Negative 13 plus or minus, and I'm going to work under this square root sign, so 13 squared is 169, minus 4 times 5 is 20, times 6, so you got a negative times a positive times a negative, so we know it's going to be plus, right? 20 times 6 is 120, and all this is divided by 2 times 5, which is 10. So under my radical, 169 plus 120 is 289. We should know that the square root of 289 is 17. So a negative 13 plus or minus square root of 289 is 17. All this divided by 10. So now here's where you get your two solutions. This comes out and says a negative 13 plus 17 divided by 10, or a negative 13 minus 17 divided by 10 is where I'm getting my two solutions at. So a negative 13 plus 17 is 4 over 10, which is the same thing as saying 2/5. And a negative 13 minus 17 is going to give me a negative 30 divided by 10, which is going to give me a negative 3. So where this parabola crosses the x-axis is at 2/5 and a negative 3. Let's look at example 3. It says, recall that the explicit formula for the sequence t sub n of triangular numbers is t sub n equals n times the quantity n plus 1 divided by 2. Is 1001, 101,475 a triangular number? If it is, which term of the sequence is it? So they want to know when this function equals this number. Okay? They want to know when this function equals this number. Now, can we make it into a quadratic problem? Sure. Let's put this in the standard form. So I got to multiply by 2. Why? Because I got to get rid of this 2. So I multiply this by 2. Okay? So n times n is n squared. N times 1 is n. Okay? My 2's are gone. Equals 101,475 times 2 is 202,950. So put this into standard form. Now becomes, all I have to do is move this to the other side, n squared plus n minus 202,950 equals 0. Okay? So my a in this case is 1. My b in this case is 2. My c in this case is a negative 202,950. Sorry, my b in this case is 1, not 2. My b in this case is 1. 1, 1, and then that number. So x equals a negative b, so a negative 1, plus or minus the square root of b squared, so 1 squared minus 4 times a, which is 1, times c, which is this big number. Sorry, I ran out of room. Divided by 2 times a, which is 1. Okay? So it equals negative 1 plus or minus the square root of. And so I'm going to do a negative 4 times this negative number is a positive. So 4 times 202,950 4 times 202,950. And then so what happens is this actually says 1 plus, underneath here, I'm just going to write this here, 1 plus 811800. Okay, so I add 1 to that. Okay, all divided by 2. So if I take the square root of 811,801, I get 901. So it equals a negative 1 plus or minus 901. That's what happens when you take the square root of that number, divided by 2. So now I get two solutions, negative 1 plus or minus 901 divided by 2. So that gives me a negative 1 plus 901 divided by 2, or a negative 1 minus 901 divided by 2. Now, if you notice here, a negative 1 minus 901 is going to be a negative 902. Can we have a negative term in our sequence? No. So this answer is not going to matter because that's going to give me a negative 1. So this is going to become then 900 divided by 2, and 900 divided by 2 we know is 450. So is this a triangular number? Yes. Which term is it? The 450th term. That's all I have for you today. Please enjoy. We'll see you tomorrow.